Hi folks, we're going to take a look at number 4 from Unit 6, Quiz 2. Okay, so let's take a look at the question. It says the sum of one number plus 4 times another number is equal to 23. Find the two numbers that give a maximum product. Okay, so here looks like I'm working with two numbers. So we'll say let x and y be the numbers. Okay, if say you were working with some kind of shape, the first thing you'd want to do is identify what the variables represent. Okay, so in any case, in any type of question like this, always identify what the variables you're using represent. Okay? Now, what I want to focus in on first, even though they give me this other information, is I notice they're looking for maximum product. Okay, so that's my focus, is that I want to deal with the product of these two numbers. Okay, so we can even say here P is the product. Okay, and that's given by x times y. Okay, so I have a function here for the product. Unfortunately, that function is given with respect to two variables. So we need to change this as a function with respect to one variable. And that's when we use the other piece of information given. Okay, so let's use this other piece of information to hopefully be able to substitute one of these variables. Now, I noticed some people had some difficulty with this line here, okay, and if I were to rewrite it, I would probably put some strategic commas here, okay, but I want you to think bedmass. So the sum of one number plus, so this is like your addition sign, 4 times another number is equal to 23, okay. I guess the way I thought of it is that you have to consider this product, the 4 times another number, before you do any addition. Okay, so I would see you writing this as the sum of one number, let's say x, plus, now 4 times another number, 4y. Okay, some people put brackets around there, but there was nothing really in here that indicated that this sum had to be done first. Okay, if I were to rewrite this, I'd probably put some commas here, say the sum of one number, comma, plus 4 times another number, comma, is equal to 23. Okay, but I guess I was thinking of going along with bedmass. So let's go with this here. You'll notice, by the way, in terms of the structure of the problem, how working with this second equation, I do on the side. I don't want to keep that in the body of my solution, because this is what I'm going to be working with, the product. So this is where I want my main solution to be. But what we're going to do here is use this to make a substitution, because now I can easily isolate x, a little easier than isolating y. So here we're left with x is equal to 23 minus 4y. And now we can substitute this into our equation. Okay, so substitute x with 23 minus 4y. Okay, multiply that by y. And now the product, first of all, is given by an equation or a function of one variable, but not just that, this function is indeed a quadratic function. Okay? So one way to do this is to multiply this out, put it in standard form, and then complete the square. And this is the solution that I have in the written solutions that I'll post up along with this here. The other option, though, is that the product is already written as sort of written in factored form. Okay, so the other way to determine the vertex is to average out the x-intercepts. So since it's in factored form already, I can calculate the x-intercepts by making p equal to 0. So 23 minus 4y times y. That means one of these two terms has to be equal to 0. So either 23 minus 4y equals 0, or the second term, y is equal to 0. So this one already done for us. Let's solve this here. Let's bring the 4y to the other side. Make it positive. So I'm just left with 23 over 4. Okay? So these are the two x-intercepts. And now what I have to do is find the average of these two to get the x value of the vertex. Okay, so here I'll use h, okay, as my x value of the vertex, okay, so I don't confuse it with the different x's and y's that I'm working with. So here it's just, well, 23 over 4 plus 0 divided by 2. So I'm just left with 23 over 4 divided by 2. Okay. Now, just in case you can't see straight off that this is 23 over 8, let's actually do the algebra to show why this is so, because I'm dividing with fractions. So we know that when we divide with fractions, it's like multiplying by the reciprocal. So this is the same as 23 over 4 times the reciprocal of the denominator, which would be 1/2. So what are we left with? 23 over 8. Okay? So, like I said, in the other solution that I'm posting, I've done it via completing the square. But keep in mind that when the function is already factored, no need to expand out and complete the square. Okay? But here, this represents just my y value that gives me a maximum p-value. Okay? So this means that y is equal to 23 over 8. Okay? If you're more comfortable, you can even, this should be a fairly nice decimal. So remember, I have no issues with using decimals. Okay? If they're nice decimals, and 2.875, that's pretty nice since it's finite. Okay, 2.875. And now in order to calculate the x value, okay, so remember this h represented a y value because that was the variable in my function. And so now I need to find the second number, which can be found by doing 23 minus 4 times y. So 2.875. And let's see what we get here. So we have 23 minus 4 times 2.875, and that gives us 11.5. Okay, now here, notice that all they asked me for were the two numbers that give me my maximum product. If they actually wanted the maximum product, I would take this number and input it into the equation to find p. Okay, had I done it via completing the square, if you look at the other solution, you'll see that it comes out in completing the square that we get the maximum product. Okay, so again, a couple of things as reminders. Always identify your variables. Set up the equation that you have to maximize or minimize. If you have to do any substitution using another equation, do that work on the side. Okay, and then once you determine your values of the vertex, you then answer the question that's actually given. Okay, that's it for this one.